Okay, I hope that everybody had a good weekend. Just a few items that are going to be coming up both this week and the next week. Let's see. Tomorrow, you're going to have a normal distribution quiz. We turned in the homework last week. If you do have any questions again on that, please let me know. Remember, virtually all of that is pretty much done on the calculator. So if you remember the keystrokes, you should be good to go. But I'm here in the morning at 7:45 if anybody has any last minute questions. Now, the standard deviation quiz we had last week, that deadline, if you want to retake it, is going to be this coming Friday by 8:05. We don't have anything else major happening this week assessment-wise until next week, when on Thursday the 19th we have our second exam. Okay, yes, ma'am.
Is there going to be a question on the test tomorrow about like what number C was the last question?
Y'all like 10C?
Yeah.
I don't believe I put one on there like that. No, that's pretty much just general concept knowledge. The quiz tomorrow, nothing like that, not that rigorous. Okay. All right, but that was a good question. So tomorrow you got the normal distribution quiz. Next Thursday we have our next exam coming up. So, be looking for it to cover standard deviation, normal distribution. We're currently on correlation. We should be able to begin linear regression, finish it tomorrow. And I was a little off on my prediction for chi-squared, but I'm hoping we should be able to go ahead and start that on Wednesday. And then we'll take into next week to go ahead and get through all that material. And everybody's aware that you have a 3-day weekend coming up, right? Okay. Don't come to school on Monday. I mean, I still got to go to work, so you're probably going to feel sorry for me. I guess if you want, I'm going to be at McKenzie Middle School. So sitting over in a corner like, John Henry, oh, you made my day. There you go, yay. Okay. All right. I think that's everything I got. The only other thing, yes, don't forget you have your next drill on Wednesday. During what period? Second period, there's going to be a fire drill. So I'm really hoping the forecast is that it's going to be raining all week. So hopefully it will not be raining during second period on Wednesday. But if there happens to be a fire drill during this class, remember you leave all your belongings here. Okay, I'm going to lock the door. Perfectly fine. Walk down the stairs past the nurse's office to the sidewalk on 19th. But then where do we go from there? So some people are throwing their hands up. There you go. Once we get to the sidewalk, we're going to walk over here to the east parking lot where the band practices. Okay, so Reese was like, I have no idea.
I haven't thought about it.
All right, but that's why we talk about it. Good. Now, you'll probably notice one other thing as you walked in. On your desk, you have a particular Batman villain. So these are what I'm going to be referring to as your villain buddies. So if I have you work on a problem in class, if I go ahead and put you in groups, I could just go ahead and say, okay, quickly get with your villain buddy. Okay, your partner in crime, as it were. So if you look around you, people around you should be groups of 3 are going to have the same villain. Or if I wanted to go larger groups, I could say Jokers and Riddlers get together. Okay. Now, just to make sure, because this has happened all through the day, is there anybody who is not sure whose villain is at your desk? Anybody not recognize it? That is the Penguin. Okay, that's the Penguin.
Oh,
Yes.
I thought
Oswald Cobblepot. Is anybody else not aware of who their villain is? Okay. Your villain is Bane. Bane. So you're right. Very good. Okay. Joey, that's Poison Ivy. Poison Ivy. Anybody else? She kind of walks the line back and forth. She's been a villain for a long time, but in like the recent decade, she's become more of a love interest for Batman, more doing good. Yeah. But she originally started as a villain. Okay.
Are you a Star Comics guy or something else?
Oh, I love Star Comics. Mm-hmm. There's a few good places around here. I like their new location better than I did their old location. Yeah, they have so much more room now. You can actually walk around and look at the stuff you want to. All right. Okay, so just in case I ever make reference to that, okay, those are your villain buddies. If you have any questions, just let me know. Okay, well, let's see. Haven't seen you since Friday. We've been talking about correlation, and we've been talking about this value R, Pearson's correlation coefficient. So what does this numerical value tell me about the scatter plot I could be analyzing? Okay. Like, for example, if I were to tell you, okay, you've got a scatter plot and it has a correlation, let's say about a negative 0.12. Well, what does that get you to think about the graph? It has a very weak negative correlation. Okay, so we know that there's enough information that we could tell the points would be falling to the right, but weak because the closer it is to zero, whether positive or negative, the further apart those points are going to be, the more spread out. Okay, so what if I were to give you maybe like a 0.95?
Very strong.
That would be very strong positive association. There we go. Now, is it possible to get a 1 or a negative 1? What kind of association did we call that? Started with a P. That is a perfect association. In fact, all the graphs that you've dealt with in your academic career, whether it be linear or quadratic, exponential, all of those models are perfect associations for that type of relationship. Does that make sense? Okay. So, thought John Henry was raising his hand. So we've been talking about all these different possibilities. We did one by hand. We've been talking about the formulas here. Okay. Does anybody remember what S sub xy represents? Started with a C. Co-something. Covariance. There we go. That's the covariance. S sub x and S sub y, what do those represent? Two words, starts with an S. Standard deviation. So S sub x is the standard deviation for your x's, one set of the data. S sub y would be the standard deviation for the y's, or the other set that you're comparing to the original. Now, these three work together. In order to find your correlation coefficient R, you take the covariance, S sub xy, and you divide it by what? S sub x times, there we go. S sub x times S sub y, a product of the two standard deviations. Okay. And you've already seen, how lengthy, how monotonous it can get if we're doing this by hand. I always recommend probably a table just to go ahead and help better organize the information that you have. We went through this one by hand, which was already done for us. Okay. And then I believe we ended up with this guy right here. Did anybody have the opportunity over the weekend to go home and fill in the table? So many hands going up. All right. Okay. But I do have it filled in right here. Okay. I had a student fill it in last year. I had somebody come up and actually, kind of fill it out, work it out with the class. I decided not to go ahead and take time to do that today. Would you like me to give you a moment or two to copy that? Because the only thing I was really thinking about doing on this problem was, again, just showing you the keystrokes, going right into the calculator. Whoa, everybody's talking at once. I can't. A lot of good feedback, though.
Just let's let the calculator work.
Okay. So I do notice there are people copying. Would you like time to copy that? Okay. So let me give you about a minute or so.
On the exam,
Uh-huh.
would we be required to do it by hand?
I'm actually putting the exam together right now. I'm kind of split on it. Part of me is kind of thinking maybe I should put a table on there. Then the other part of me is thinking maybe I should just go ahead and focus on the technology aspect of it. Whatever I do decide, I will let you know. Okay. We'll let you know about that. The only thing I'm fairly certain of right now, because we are starting the chi-squared test for independence on Wednesday, or at least I'm hoping by Wednesday, I don't believe that is going to be on the test. Okay, I mean, if we are able to finish it in time, fantastic. Otherwise, we'll probably just focus on the other items. Come on over here. Okay, now one of the big items while you're copying this down that we did bring up on Friday when talking about correlation, very, very important phrase. Correlation does not mean Causation. So let's say you are able to identify Pearson's correlation coefficient, that value of R, and you get either a very strong or a very negative association. That doesn't actually mean that one affects or causes the other in some way. Now, there might be some relationship. Odds are you might be comparing two quantities that have nothing in common, and you were still able to get one. I believe the example we did the other day, wasn't it the size of a person's foot and the reading level? Okay, they were able to end up with a very strong positive correlation, but there is no connection between the size of your foot and how well you read. Okay, I mean, you always want to put your best foot forward, but that's something. Oh, goodness me. Okay, so I'm going to go ahead and put these in there. Someone's going to have to help me because I don't have the copy of the notes in front of me. So the first thing, let's say I want to go ahead and figure out what the correlation coefficient for this is. Okay, remember, here are all the formulas if you're going to do it by hand, but let's go to the calculator. Okay, so I always like to choose number one from my home screen. Okay, list of spreadsheets. You can also choose the icon at the bottom. Okay, so X, we always have to put in our column titles. We always, again, want to avoid this row right here, the equals row. Okay. And I'm going to go ahead and take one quick glance back. Let's see, it was 2, 4, 5, 7, 2, 4, 5, 7, 9. What was it after that? 10, 11. And was there another one, or was it just 7? 15. Was there only 8? Okay. All right, so there are my X's. And what corresponds to 2? 3, 4, okay. Okay, so I got my data in. Always a good idea, go ahead and take a second just to make sure your data is correct. Okay, it'll save you a lot of trouble, later on if it isn't. So I'm choosing an empty cell. Can anybody remind me of the keystrokes if I want to find the correlation coefficient? We do go to menu. Okay, that's generally our first step. Statistics, stat calculations. We want two variable. We are actually comparing two different sets of data here. So yes, we want two variable statistics. Okay, so your X and your Y list are the headings that you originally put in. Always choose X for the X list or whatever you chose to put in. Okay. Let's see here. I want the Y for that one. The frequency list, even if you remove that one, it's still just going to reappear. Okay, so don't bother with it. Looks like all my information is going to appear in column D. As soon as I click OK, let's see. Okay. All right, so it looks like the mean of the X is 7.875. There's the sum of the squares. Which one is the standard deviation? S of X or sigma X? Sigma X, 3.9. Remember, that was a descriptor. Okay. Number of terms were 8. There's the Y mean. Okay. Standard deviation for that. And there we go. So that correlation coefficient turned out to be about 0.969. If you want to round it to 2 decimal places or 3 sig figs, depending. So how would you describe that correlation? That is a very strong positive correlation. In fact, that is very nearly perfect. Okay, only a few of those points should probably be slightly off if you were to go ahead and draw a line through there. Okay, so let's say about 0.97. There we go. Perfect. So let's see. R is about 0.97. Okay. Any questions? All right. Okay, well, we're going to get the opportunity to continue working with this because we're going to move on to linear regression, which is actually still dealing with scatter plots, but now we're going to be looking at the prediction equation, that trend line that I mentioned previously. Now, the only document you picked up today when you walked in was the assignment for this. Let's go ahead and say Wednesday is when it'll be due. Okay. So a lot of what you're doing on the homework here, the technology, probably not a bad idea to go ahead and draw a scatter diagram. In fact, using a ruler is something that very well could appear on one of your paper exams. They did that last year. They instructed the student to go ahead and create an increment, every half inch. They would number the axes, and they created a graph using a ruler and pencil during that exam. So it's not uncommon that they could ask you to do that. Okay. I believe only one of these I'm actually having you fill in a table and do it by hand. Okay. And now we got linear regression. So this is really going to go back into the good old Algebra 1 days. So a little bit of walk down memory lane today. Linear regression is a method of fitting a line to a set of data and then finding the equation of the line. Okay, the regression line is often called the line of best fit because it will not hit. I passed this out last week. You remember when I made the mistake? I passed out this set of notes before. Remember? Because remember Friday I called myself a silly goose? I said I was teaching the right lesson, but I passed out this set of notes. No, I passed them out like Wednesday or Thursday.
It's the ones that you gave us earlier are all the same as the packet that you gave us the next day.
What?
Except it's different order.
It is? Well, there's the scatter diagram. Okay. And what was it? What did I give you originally?
That was what you gave me originally, and then
Okay.
this is the new one. Wait, that's the new one. That's all.
Well, what happened to the linear regression notes? Now that I could have sworn I accidentally passed out. Huh. Yeah, no, those I don't have any more copies of those. You sure I didn't pass those out? Yeah. Okay, so what I'll do is I'll make sure that I'll get copies of those quick, and I'll make sure to get them to you tomorrow. I could have sworn I already passed those out. That's weird. Okay, so I'll go ahead and do this. For this first problem that we're going to go ahead and work, I do have this grid paper here, so that'll help out for today. Yay! Yay!
Wicked grid paper.
Okay, so for this first problem coming up, we're going to go ahead and talk about the linear regression. Yes, sir. Yeah, right now, sir. Okay, at least we have a grid. No, it looks just like that. It says linear regression.
Is this what we got?
I could have sworn. Guess I made a mistake. Apologize for that. That's okay. I'll get you a copy of that tomorrow, so you don't have to worry about that. Probably make the copy first thing when I come in the morning. Okay, here we go. There we go. All right, so for today, we'll just go ahead and talk about it. Like, you don't have to worry about copying this down because I'll go ahead and get that to you tomorrow. But we also refer to this. Now, what do I do with my marker? Everything's disappeared on me today. Okay, so the line of best fit, we also refer to that as the trend line. We can also refer to it as the regression curve, even though we are talking about a linear function. All of those words are going to be interchangeable. So, vocabulary, don't let that throw you off if you see it on a paper exam. But what we're going to go ahead and do, there are two ways of finding a line of best fit that we're going to study, fitting it by eye, and then the least squares regression line. So basically, we're going to do one of these by hand, and we're going to go ahead and do one of these using the technology. Okay, so basically this first problem, we're going to spend probably the rest of the time on it today, which is good because we don't have the notes. Okay, so the line of best fit by eye method. Make a scatter plot of the data given. So basically we're just plotting the ordered pairs. Okay, group X times group Y. Find the mean of the X coordinates and the mean of the Y coordinates. That is this point right here, what we refer to as the grand mean. Okay, so it's an ordered pair where the X value is the mean of the X's, the Y value is the mean of the Y's. Now, when you go ahead and write your prediction equation, your trend line, your line of best fit, whatever you call it, we do want to go ahead and put it in this form. What do we call that? Okay, slope intercept. But we want to make sure that our line contains this point, the mean of the X's and the mean of the Y's. We want it to contain the grand mean. That just adds some legitimacy to it, especially if you're going to go ahead and use it to predict based on your data. And in fact, if anybody is already considering using correlation coefficient or a regression line on your internal assessment, this is definitely something that you want to go ahead and include. Does anybody remember, because we'll have a point and we'll have already determined the slope, does anybody remember what point slope form is? Y minus y1 equals m times x minus x1. Good. So this x1 and this y1 point, when we write the equation by hand, that's going to be the grand mean. And then I'll show you how we'll determine the slope. Okay. All right, what else we got here? By I, draw the line which best fits the data with an equal number of points on either side through the grand mean. Pick 2 points that are close to the line that you drew and find the equation of the line passing between them. This is going to be the equation of the line of best fit. Okay, well, here's my first example. And I think this is cut off in 2 places. It says the heights in centimeters and weights in kilograms of a hockey team are recorded as follows. Okay. So we have the heights, which is my x values, and we have the weights in kilograms, which are my y values. And it looks like they sampled how many players? 20. 21. There we go. There are 21 ordered pairs here that I'm going to be looking at. Okay, so the first thing, we want to go ahead and make a scatter plot of the data from above. So you'll notice, even though this corner right here, I'm going to start it at 0. Okay, the lowest I can go with the x's, I'm going to go with 160. And then I went up to 190. That'll fit the data nicely. And then here, I just used this first line. I started it at 60 and then went all the way to 85. So that should take care of all the centimeters and weights that we're looking at. Well, that right there is just what's going to take a few minutes. We just have to plot the points. Okay, so we've seen how fascinating it is looking at my back while I'm plotting points. Who wants to come on up here and help me with these points? Or I'll tell you what, we'll break it up. There are 21 points. How about we get somebody to take care of the first, let's say 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The first 11 points, and then we'll get somebody up here to finish off the last 10. A lot of hands going up. Hey, somebody would want to come up. It's been 2 whole days since you've looked at math, right? Shirley. Okay. Do I need to use a random number generator? I'll just use the calculator here. Let's see here. Okay. A. So I'm going to say menu, probability, random, integer. Okay, so 1. And I believe at most there's only 30 of us in here. Okay. 5. Oh,
Wave of relief.
that was Ella. Now, Ella, let me ask you, have you ever come up to the board before? No? Okay, good. I thought you had. Come on. Yeah. But darn. Okay. So all we need to do is plot these points, like 183, 85, 170, 74, and then we'll just go from there. Now, Ella, would you like the earphones?
No.
You don't want to talk to the people?
No.
Okay. Well, at least say hello.
Hi.
There you go. Okay. All right. So let's see. So the first point, 183, 85. Okay. So I would agree with that. So that's 1. 10 to go.
Oh, God.
Okay. So 170, 74. Okay.
Is that wrong?
No, that's right.
Oh, okay.
There. And then 174, 76. Okay. 168, 69. Okay. Good. Everybody's intently focused on Ella's point skills. I would say she's on point. Oh, mercy. Okay.
77.
So 177, 74. Okay. I would agree with that. 162, 62. Okay. Next, 167, 67. There we go. So those points are very close to each other. 169.74. Okay. 163.67. Okay. And last one, 161.69. There we go. Now, unless Ella wants to, oh, and she's already walking away from the board. Okay. All right, so that's all you got to do. I just need another person to come on up and give me these points right here. Let me go ahead and define them just a little darker here so we can see those. She did a great job. No, I'm not redoing it. I'm just making them slightly larger so people at the back can see them. She did great. Okay. Now all we need are the final 10 points. Who wants to do that one? All right, Sarah Beth. Okay. And then I'm going to ask for your help. We also want to go ahead and find the grand mean. Okay. So let's say this side of the classroom, I need somebody to determine, everybody can work on it, just somebody tell it to me when you get it. I need the mean of the x's, okay, the heights in centimeters. Everybody on this side, go ahead and try to find me the mean of the y's, the weight in kilograms. Okay. All right, let's see. Which one are you on, man? Are you on the first one or are you on the second one? Okay, so 160.64. Okay, perfect. So 160.62. Okay. One 167.62. 71.69. Oh. Yeah, the sensor isn't perfect. Okay. And then 171.69, okay. 170.76. Okay. 174.71. Perfect. 162.71. Okay. 187.84. Okay. And last up, 175.77. Okay. 175.77. There are all 21 points. Yes. All right. Now, let's go ahead. Okay. Who over here has found me the mean of the x's? By show of hands. Who thinks they got it? Okay, Stephanie, what you got? Ooh, I got something slightly different. It's very close.
We're doing the heights.
We're doing the heights in centimeters. Okay. While we're working on that, has anybody got the mean for the weights? Okay, Lizzie, what'd you get? 71.6. Okay. I got 71.7. So mine's just slightly off, so I'd say that's good. Okay. But we are a little further off on the x's. Has anybody figured that out yet? Oh, that's even further off, sorry. Still kind of high. I'm getting 169.52. Okay. Maybe I'm wrong. 169.52. Now, the last time I did look at this was last week, so it is possible. Okay. They do. They actually do from time to time. All right. Okay. So we've got the scatter plot. That's easy enough. You're just plotting points in a plane. Okay, the horizontal versus the vertical axis, whatever increment you're going to use. Okay, so find the coordinates of the grand mean. Okay, using the means we found. Okay, we're going to go with 169.52, and then the other one, 71.7. Okay. Now it says sketch a line of best fit through the data by eye. So I want to make sure to go ahead and plot this point. So 169.52. So 169.5 will be right about here, about halfway, a little over. And then we have 71.7. So maybe right about here. Okay. The one in red is going to turn out to be my grand mean. Let me make that a little larger. Okay. Now, when it means sketch the line, we want to try to put the line again through as many of the points as possible. Definitely not going to be able to hit every one of them. This is not a perfect association, but I'm looking for about as many points above as would be below. And I definitely wanted to go through this grand mean right here. So I'm probably thinking something like that. Okay. That would be my trend line. My line of best fit, my regression line. Okay. All right. Now it says pick 2 points close to the line of best fit that you drew and find the equation of the line passing through those points. This is the line of best fit by eye. Okay, so what I want to go ahead and do, what 2 points do you believe are closest to the line I drew? Okay. 168 and 67. Let me go ahead and do this in maybe a different color here. Okay, so 168 and 67. 163. 63 and 67. So that point right there, I'd say that's really close to the line. That's a good one. What do you think? It'd be another one? 177 and 74. Okay. There's 74 right there. So that point right there. Okay. Not perfectly on the line, but that's okay. We're going to try to choose points that we think are going to work best. Now remember, the way I drew the line, how many other ways could somebody have said this line fits their data better? Is everybody's line going to be in the exact same position? No, and just by that idea, how many different points do you think people are going to choose? Probably quite a few different points. Let's just go ahead and say we're going to work with those. So we got, what was this first one? 163, 67? Okay, so 163, 67. And the other point we chose, what was it, 177, 74? Okay, 177, 74. Now we're wanting to go ahead and figure out what the equation of this line is. Well, if you're going to write the equation of a line, what's paramount? What do you need more than anything? You need the slope, your rise over run. So how do I find the slope given 2 points? Remember, what's that formula? There you go. So the slope m is y2 minus y1 over x2 minus x1. Okay. So let's see here. Difference of the y's, 74 minus 67 over 177 minus 163. Okay. And let's just go to the calculator on this one. Okay. Let's get out of here. Let's go home, calculate. Okay. Control divide. And I've totally forgotten the numbers. 74 minus 67. 74 minus 67. And then what was it? 177 minus what? 163. 163. Would you guys agree? Okay. What should I be getting? Okay. 1/2. So let's say 0.5. Okay, 0.5. Now, take a look. Just based on where I drew my line, one of those points is very nearly on it. We tried to choose another point that was very close, but it's definitely not on the line. Again, it's what I like to think of as in the ballpark. We're going to be close, but it's not going to be perfect. What's probably the best way to figure out the equation of the prediction line, the trend line? Using what? using the technology. I mean, this is something that you could do, and they like to see this on your IAs. In fact, you could even throw in a discussion about it. For IB, it's all about, the journey, not what you're getting out of it, but especially those of you who have been in CAS before or who are about to go through CAS, that's really what they're looking for. It's about you progressing as a person, right? That's really what they look for. I mean, that's not a joke. You guys are kind of looking at me like, the journey, oh my goodness.
Maybe the real journey is the friends we made along the way.
Hey, there you go. I like that. That should be on a fortune cookie. All right. Where were we? Anyways, now you don't necessarily have to do that, but again, let's say that for your IA, the data you chose, you want to go ahead and use this. Now remember, I did say it's a really good idea to go ahead and show this by hand. Okay, you do want to go ahead and create the table. So whatever you come up with by hand, depending on especially if you round, that answer could be potentially different from what you get using technology. So you could include a little discussion of that. Just maybe why your answer was off because of how you rounded, or maybe why you decided to round the way you did. Okay. All right, so we got my slope, which was, we'll say 0.5. Okay. So now I'm going to go ahead and use my point slope formula, and let's go ahead and figure out what that is. But what's the point I want to use if I'm going to write my equation? Remember, what was the general form we talked about at the very beginning of class? If I have a point and a slope. Remember, point slope formula. There we go. Okay. So I have my point, this right here. I'm going to use the grand mean. And I've got my slope. We just found it to be 0.5. Because this is in decimal, I'm just going to go ahead and change the 1/2 to a decimal. And let's see what we got here. Y minus y1 is equal to m times x minus x1. Okay. So y what? Minus 71.7 equals the slope m 0.5 times x minus 169.52. 169.52. Okay. Well, now all we got to do is just rewrite this guy into slope-intercept form. Okay. Remember, this x right here and this y, those are what we call generic variables. They're going to be there as part of the equation. You typically always have x and y. All right, so I would just distribute. So y minus 71.7 equals, okay, 0.5 times x would be 0.5x. And somebody help me out. What's 0.5 times 169.52? I honestly don't know that off the top of my head. 84.26? Okay. Would you guys agree? I don't know. It's what? 7.6. So we were close. Hey, that's all right. It's all right. I make mistakes too. Okay. I make a lot of mistakes, so just get ready. All right. All right, so everybody's agree. 84.76. All right, last step. I'm going to go ahead and say y equals my 0.5x. Well, if I go ahead, if I add that over, negative 84.76 plus 71.7. Okay, negative 13.1. 06. Okay. Okay, and Emmy wants to know, John Henry, are you judging her?
Yes.
Okay. Making sure. All right, so there we go. Okay. You guys remember writing equations way back in Algebra 1? So that's the good news. I mean, you're doing this by hand. You're just falling back on those skills that you've already known for quite a while. Okay, so this is a scatter plot. Questions? Okay. Well, now from here, we could actually go ahead and use this, depending on how accurate we believe the findings would turn out, to go ahead and predict, okay, if we had a certain height or if we were given a certain weight, what would the corresponding quantity be as a result? Now, if I were to do so, if I were to go ahead and say, all right, well, now I have a height of, let's say, what's one that I don't see up there? There wasn't a 161. So if I said I had a height of 161 centimeters, you could then go ahead and use this to go ahead and figure out what the corresponding weight would be, the corresponding y value. Okay. Now, how accurate do you think it's going to be?
I don't know.
What's that, John Henry?
Fun to find out.
It is going to be fun to find out.
Did you say there wasn't a 161 on there?
Did I mess up again? There is a 161? It's a Monday. That's all I'll say. All right. Is anybody having trouble? Anybody not sure where we're getting these values from? Yes, Amy.
I was going to ask about outliers, that how would you know how far away it is?
And, you know, that's the thing. The more experience you have, you'll have a better idea. But the good thing with these, they're almost on the same linear path. I'm sure you're referring to these guys right here. But, you know, it depends. If you had all of these points, but let's say I had an additional ordered pair given, like maybe it was way up here. Okay, kind of think about it in terms of the average. You still want to include these, but that as well, so you might end up with a line that looks like that. Okay, so it really depends on your data. And in fact, I'm glad she brought that up. We did talk about this previously. If you do have a set of data like this, but you have one ordered pair that's just radically different from the others, should you still include it? Yes, you still want to include it. Okay, even if it changes your outcome, you definitely do want to go ahead and include it. Oh my gosh, 205. Wow, time flies when you're having fun, right? Okay. So I do apologize. I will have those notes ready for you guys tomorrow when you come in. We'll go ahead and do a few more examples, and we should hopefully be done with the linear regression. Okay. When's the homework due? Homework's due Wednesday, and remember tomorrow we have a quiz over normal distribution. Yes. Okay, this is number 8.